This next part can look very overwhelming, so let's not look at it. There, it's gone. No, actually, let's instead draw some stuff. Let's suppose that we are plotting a point in polar coordinates and we're going to plot some r and some theta. That means that we would move out some distance, we'd move out and then we'd move around, and so we're going to have just some point. Now I know that looks rectangular like what you're used to seeing, but we moved out and around. And this distance right here is r. Well, let's kind of bridge the gap between polar and rectangular. No one's surprised when I say that this is the y value and this is the x value. And when we moved around, let's just make it all colorful. We moved around some angle, we'll call it theta. So here on this picture, we have all kinds of stuff, and it's all stuff you've seen before. You could go x, y, or you could go radius, and then swing that radius around, and there's your angle, and that is the length of your radius. You could do that. So either way is gonna work. Here's what we're gonna do. We're gonna come up with just a whole bunch of stuff that is gonna be common sense, and then when we put it in context, you'll remember this better. So let's do it. What color have I not used? Purple. Let's go for that. Let's go with purple. First thing I notice is that I have a right triangle, and this right triangle has an x and a y and an r. Done. Pythagorean theorem. So if I ever know two of the three of these, I can find the third one. Now, most of the time, you'll know x and y, and you'll need to know r. So here you go. If I know rectangular coordinates, x and y, and I need to know r, I can use that. I can also, if you're looking ahead here, I could also, ignoring r, assuming I don't know r, I can find the angle by saying, well, the tangent of my angle is going to give me y divided by x. Now, I do need to be careful with that because this triangle may not appear in the first quadrant. It might be over here, 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 and we'll cross that bridge when we get to it. But we need to be cautious of where the actual angle is, where the coordinate lies, and that will determine the angle itself. We can do some of the basic computations, but at the end, we're going to need to consider, am I in quadrant 1, 2, 3, or 4? You'll see what I mean when we get there. Out of context, it doesn't make much sense. So, this is going to be if I know what's rectangular and I want to turn it into polar, like I'm looking for the angle, I'm looking for the radius. All that is already on your paper, and then you can see where this one's going. We're going to start with the r and the theta and get x. Start with the r and the theta and get y. And you can see the formulas, but let me show you where they come from. If I wanted to use two of the things that I know, and I know r and theta. Like I'm starting with r and theta, and let me mark it out here because it looks a little out of context there. This is where I start with x, y, and I go to r theta. And then if I wanted to go from r theta to x, y, then I would be going from polar to rectangular. And in that case, again, what I do know is r and theta. So I'm going to make an equation that has r in it, has theta in it, and I need the other stuff. So if I wanted to get x, well, x would be the adjacent side, and that would be the hypotenuse, so I would use cosine. So the cosine of theta is equal to x over r. And then just kind of taking that logically where it goes, if I multiplied by r, then I would have r cosine theta. And that's where this comes from. And we're going to do it again. So I wanted to know why. I want to know why. Tell me why. I would do sine of theta. That was also almost a cosine. Also a cosine. Almost a cosine. Almost wrote the wrong thing is what I'm trying to say. Sine of theta would be opposite over hypotenuse. So opposite over hypotenuse. And you can solve this for y. So y would be r sine theta. And that is where all this comes from. So it's an excellent way to remember that. Let's apply it. So we're going to convert each of these polar coordinates below into rectangular coordinates, and I am starting with polar. I'm starting with r and theta. I'm going to end with x and y, and we'll stick with the purple pen. So my x coordinate is r cosine theta, and I personally like to write the formula each time. I didn't that time, so my apologies. But r cosine theta, and the more you write it, the more you'll remember it. But of course, if you forget it, Go back to here. Draw this, and this can logically flow from it, and so can this. Okay. I wrote r. I meant to put a 2. Let's fix that. 2 cosine theta. So I could put r cosine theta, or I could put 2 cosine pi over 3. Don't mix them up. All right, so cosine of pi over 3, cosine of pi over 3, 1/2. And that's going to give me 1. All right, well, y is 2 sine pi over 3. And sine of pi over 3 is square root of 3 over 2. And that gives me square root of 3. Okay, let's put this in context, actually. Here's what this means. My r theta converts to an xy value of 1 square root of 3. So my xy is 1 comma square root of 3. Flip your paper over. Mine's on a separate piece of paper. That was coordinate A. 2 pi over 3 is what you just did. You just converted it into rectangular coordinates. This coordinate is at, rectangularly, 1 comma square root of 3. Square root of 3 is about 1.7 something, 1.732 something. So almost 2-ish. So 1 and then up towards 2. And that, like, looking at the scale and the proportion, that makes sense. Go over 1, go up 1.7. There's A. Let's do the next one. This is fun. So x is, I'll write the formula this time. I don't want to forget it. R cosine. So negative 3 cosine pi over 2. And y is r sine. If you don't want to write it every time, that's fine. But the more you write, the more you remember. There we go. Let's see. Cosine of pi over 2 is 0. And sine of pi over 2 is 1. So my xy coordinate is 0, negative 3. This was, front page, coordinate C, and you could have figured that one out just by looking at it. So sometimes it's faster if you look at this number and decide, oh, is this on an axis? And if it is a multiple of pi over 2, if it's a multiple of pi for sure, that's on your x-axis. If it is a multiple of pi over 2, but not a multiple of pi, then if your denominator is 2, basically is what I'm saying, then it's going to be on the y-axis, and you don't have decimals and stuff like that. Anyway, graph it and look. I'm getting wordy in my explanations to cover all the exceptions, but yeah, anyway. R cosine theta, man, I should go back in the video and just erase all this and write the formula again. Or not. Cosine 5 pi over 4, and then we'll leave a little space. That's going to take a little work. R sine theta is 3 sine 5 pi over 4. All right, let's keep going. All right, cosine of 5 pi over 4. Cosine of 5 pi over 4. Let's see, that puts me in the third quadrant, and that would be square root of 2 over 2, only it is negative. So 3 times negative square root of 2 over 2. So this is negative 3 square root of 2 over 2. All right, sine is going to be the same at this place. It is also negative square root of 2 over 2. So negative 3 square root of 2 over 2. If you need to draw the unit circle in your head, at least, do it. And so my xy value for this one is negative 3 square root of 2 over 2. And then same thing, negative 3 square root of 2 over 2. All right, sliding up. Convert the rectangular coordinates below into rectangular coordinates. That's a typo. Done. Let's convert the rectangular coordinates below into polar coordinates. Yours may not say that depending on when you're watching this, but the earlier versions of these notes are wrong. So let's convert them into polar coordinates. Man, that'd be a short lesson. Convert this into the thing that it already is. Done. Great. Okay, convert the rectangular coordinates below into polar coordinates, and just because I made such an egregious error, let's switch colors. Let's switch to green. This is an X, this is a Y, and I want to find the R and the theta. So my final answer here is going to be R comma theta is equal to something, something, something. And I don't know what it is. Now, I recommend, highly, highly recommend, that we just graph it. It doesn't have to be perfect. This can happen in your head, but I need to know that it's at 2, negative 2. I need to know the quadrant. That's really what I'm dealing with. That's going to be very important. I'm dealing with this right here, that point right there in quadrant 4. And the reason that's important is because I'm going to have to pick my angle very carefully. Very carefully. I make it sound like it's the most important decision of your life. It's not. And I didn't write the formula down, but here's the formula: x squared plus y squared equals r squared. It's the Pythagorean theorem. So we have 4 plus 4, that is going to give me 8. So 8 equals r squared. So r is the square root of 8. We'll call it what it is. That is 2 square root of 2. So my r value is 2 square root of 2. Okay, good for us. We are going to find the theta value there. And the theta value can be found by doing, well, let's squeeze it in there. Tangent of theta equals y over x. And so here's what I need. I can do this one without a calculator, and I'm going to do all these without a calculator. If I grabbed a calculator, it would work, but it's just not what I need. Because it's going to give me decimals, and I really want to have pi's in this, because these are pretty enough to where they're going to work out neatly enough. So I need to know where tangent is -1. So where is tangent -1? Well, that happens in this quadrant and in this quadrant. So it was important for me to know what quadrant I was dealing with so I can pick the appropriate one. Now, where is tangent -1? Tangent is -1, again, at a couple places, but we're going to have the lights go out again. It's -1 at a couple places, and one of those places is right here. The other one's here, and this one's the one I need. And tangent is 1 or -1 at the pi's that are divisible by 4, like pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. And this is 7 pi over 4 right here. 7 pi over 4. Good to know the unit circle. I'm going to stand up and turn the lights on. Some people use light switches. I just stand up and kick the chair, just in case you heard that. All right, here we go. Final answer on this next one is going to be an r and a theta, and it's going to equal something, something, something. Don't know what yet, so let's find it. First thing I'm going to do is write the formula this time. X squared plus y squared equals r squared. You don't have to write it, but the more you write, the more you remember, and the more I say that, the more you're like, okay, I got it. It's r squared. Okay, this one's going to get a little tricky. That is 4 times 3. That's 12 plus 4 is equal to r squared. 12 plus 4, last time I checked, was 16. So r squared equals 16, r equals 4. Now you could be like 4 or -4. Yeah, sure, play that game if you want to. Let's just call it 4. And because I at least need to know where it is, this can happen in your head. There it is, -2 square root of 3, comma 2. Don't panic about exactly putting it in the right spot, but you know what quadrant it's in. And that's going to come in handy for the next part. The next part, what's the next part? That is where I find the angle, and I will do that with tangent of theta equals y over x. So tangent of theta equals y over x. Oh boy. Okay, we're going to cancel the 2's, of course, and we're going to have -1 over the square root of 3. And that does not show up anywhere on the unit circle that you're used to seeing. But if you multiply by the square root of 3 over the square root of 3, then what you're really dealing with is everywhere that tangent is negative square root of 3 over 3. Okay, that occurs, first of all, it occurs where tangent is negative, which is in quadrants 2 and 4. And it is going to occur at the ones that have a 6 in the denominator. So it's 5 pi over 6 or 11 pi over 6. And we're over here, so it's going to be 5 pi over 6. Got it. All right, this next one's super easy, super duper easy, and we're not even going to use our formulas. We could, but I'm not. Let's just plot it first. Done. Okay, what quadrant? It's not in a quadrant, it's on the axis. Fantastic, that's good to know. So my final answer for r and theta is, you might be like, oh, -4, 0. That's rectangular thinking. We're thinking polar now. So if I wanted to get here, what could I do? I have a couple options, actually. I could say -4, 0. So like 20 seconds ago, I said -4, 0 is not correct. It actually is, because I could have a radius of -4, which gives me the direction to the left, and then an angle of 0, which would work. So this does work. Or, and let's think outside the box. Oh, there you go. Or you could go forward 4 and then around half a circle. So I could go forward 4 and then around pi. Or negative pi. Or 3 pi. There's lots of answers. Either one of those will work. And you can get all these answers by doing that. But this one was a little more obvious.